Good afternoon, fellow Foundryman. This is Sandil Kumar, Secretary of IF Chennai Chapter. Before we start things, I am requesting everyone to put yourself mute and also switch off your video so that we can give a focus to the speaker. And it gives me immense pleasure and interacting with you for yet another webinar, which is regularly being conducted by IF Chennai Chapter. I'm sure every one of you must be very busy during the last month of this financial year. We thank you for sparing your time, even though in your busy schedule. And today we have a topic of process of heat exchange between two fluids, a different approach for foundry equipment and maintenance. The speaker by Mr. Ram Shankar, Manager Sales R&D Engineering. I think we having a maintenance related topic after a long time. We had a fantastic session last year from Mr. Sundaresan sir from Brakes India. A lot of people have benefited. To welcome the gatherings formally, I'm requesting our chapter chairman V.K. Raman sir to welcome the gathering, please.
Welcome, Mr. Ram Shankar.
Yes, sir. Good afternoon, sir.
Thank you. Good afternoon. So, on behalf of IF Chennai chapter, I welcome all the fellow foundrymen for this wonderful webinar. Today's topic is really a very different topic related to maintenance. See, in any foundry, the maintenance plays major role in terms of achieving safety, quality, and in fact productivity. So for predominantly the quality parameters where we need to achieve through maintenance is very vital. So in that context, today's topic is about maintaining the foundry equipments with a different approach where heat exchange happening between two different fluids, which will be explained and fully detailed by Mr. Ram Shankar. Ram Shankar is having wide experience in establishing those facilities in many foundries. So, on behalf of Chennai chapter, again, I am welcoming you all and attend this program fully. You may raise your question at the end of the program, where Ram Shankar will be in a position to give full explanation for any questions. So now over to our secretary, Mr. Senthil, to take thereon. Thank you.
Thank you, sir. Thank you. Gentlemen, I think the topic and the chairman has briefed about the speaker, and I think as we all know that maintenance is very important factor, and in this, I think today topic is going to talk about the innovation aspects, and the company name is itself different, R&D Engineering, and let's hear from the speaker. Before that, I would like to ask our council member, Mr. M. Prasad, to introduce the speaker to the audience, please.
Thank you, Sindhu sir. So it's my pleasure to introduce today's speaker, Mr. A. Ram Shankar. He is basically a diploma in mechanical engineering graduate, and he is having a total 18 years experience, including 3 years in Univa Engineers as sales engineer, 1 year in Premium Gearbox as a South Indian sales tip, then 3 years in work group of companies, and currently is working in R&D engineering as a sales manager for the past 10 years. I request Mr. N. Ramesh is also joining in today's program. He is a proprietor of R&D engineering. He is having a 26 years of experience in plate heat exchanger and chiller. So thank you, sir.
Good afternoon. Good afternoon, everybody.
Good afternoon, sir.
And also, I'm Ram Shankar. My boss also joined actually along with me. He is Mr. Ramesh. N. Ramesh is the proprietor of R&DS Engineering. If you have any inquiries or any doubts on maintenance support PHEs, we can share our slides first. If you have any doubts, you can ask the questions.
Sir, good afternoon, everyone.
Good afternoon,
Can you
sir.
hear me, sir?
Yes, sir. Yes, sir. We are able to hear you, sir.
Yes, sir. This is Ramesh from R&DS Engineering. First of all, I would like to thanks to the Mr. John Selvin, sir, who has given this opportunity, to furnish our background experience to all good people. And of course, special thanks to Mr. Raman, sir, and other Shekhar, sir, to everyone and all the team members. I hope that some various part of the states also joining here.
Yes,
First,
yes.
we will go through like our introduction of our basics from our company background, and then the about plate heat exchanger, types of heat exchanger, applications, and the advantage of plate heat exchangers compared to others. So these are the three topics, and then we'll move forward about what we did it in Ashok Leyland, the Foundry division at Sri Perumbudur. So these are the topics which we are going to cover. Is that clear, sir?
Yes, sir. Yes, sir. Please go ahead, sir.
Yes, sir.
Yeah, go ahead. Go ahead.
Yeah, yeah. Sir, our company, of course, let me tell you my background. I started my career with this company called Trenter in 1998. And then I was working with them till 2013. I was heading South India as a regional head. I was covering entire South India as well as the Sri Lanka business activity. And then 2013, I had an opportunity to become an entrepreneur. So by the time for Chennai, Trenter was looking for one channel partner. So they asked me to lead this channel partner. So that is how my company started. So we started in 2013. Just we completed 11 years in this plate heat exchanger as an entrepreneur. And the total my experience around 26 years only in the plate heat exchanger and the chiller. Right now, our company size is around 10 crore, which we are doing it in Chennai. This is our geographical, in Trenter, there is a area restriction. So, which we are covering Tamil Nadu, Kerala, and part of Andhra. Now we can do business up to Nellore. So these are our territory. And my team is almost, we are having 8 people with this plate heat exchanger, 2 engineer for sales, 4 engineer for service, and 1 sales coordinator and 1 admin lady. So total we are 9, including me. This is our company size. See, this is this slide which will tell you about our what are the products which is available in our baskets. Number 1 is plate heat exchanger, which we deal the company called Trenter. About Trenter, this Trenter is almost 9-decade-year company. It was started in 1934 in US, Texas. They started with a small, plate coil those days. So the electrical electronic goods, they used to, transfer from one place to other place. While transporting time, the electrical peripherals all needs to be cooled. So that they used to cool the equipment with the help of refrigeration. By the time they started the product called plate coil, it is something like a coil type. So inside the coil, they circulate the refrigerants. So that is how this company had started. And slowly they're getting to the plate heat exchanger. In the way back of around the 50-60 years, then they acquired a company called SWEP. SWEP is basically into the plate heat exchanger and the brazed heat exchanger. This is the company background, and now this Trenter has a global manufacturing setup. One is in US, Texas, which cover American countries and North American, South America. One more factory is located at Sweden, which covers the European market. And one factory is in Korea. One factory is in India, which is located at Pune. And this Trenter has all the accreditations like, ASME, we can provide you the ASME standard, PED standard, National Board, SQL, ISO, whatever the standards available for the plate heat exchanger, everything's available with the Trenter. So we can, many times we do export also, we take intercompany order, like, Trenter, US take the order and manufacturing it in India, which is catered to the US standard. So we take now intercompany orders also. So India factory has all the facilities, all the accreditations. And our next product is, we are into refrigeration also. That is chiller, which we deal the company called Werner Friendly, which is located at Bangalore. This company also almost to 4-decade company. They started in 1984. Then now they completed 40 years experience in the chiller field. And this Werner Friendly is recently they joined with a company called Gland Dimplex, which is Ireland-based company. They're the world #1 leader in the process cooling system. So recently, this this Glam Dimplex has taken over the stakes of Wonderful. Almost now they are 51% shareholder. And this Wonderful, they're very specialist in the process cooling. They're not into the HVAC cooling. They're into the process cooling. This Werner, under the Wonderful, they manufacture process chillers, panel AC, which goes into the panel cooling, and stouts also they manufacture. So these are the major 3 products which is available with the Werner Finlay. And another product is which we deal is the product name is again this is plate heat exchanger. We call it as a compact brazed heat exchanger. The brand name is Swep. Again, Swep is a Swedish company, and this brazed heat exchanger goes into the refrigeration market. This goes into the chiller as a evaporator. So which we are the authorized dealer for Tamil Nadu. And the next we handle the burner, which the Balto, the brand name is Balto. This Balto recently we started associating with this company. So I don't want to talk much about this burner, just we started. And another one more company which we handle the round disc, or we call it sir RDRO. This is manufactured by a company called Neertech, which is based out of Mumbai. This is the RDRO basically goes into the effluent reject. Before ME, we recover the heat with a higher efficiency. That is the reason. And this RDRO technologies, we have a joint venture with a German company, Deflora Water. This is for water treatment. These are the product which is available with us. Sir, if at all any doubt, please stop me so that now I can give you the explanation. Now this is now types of heat exchanger. See, basically the heat exchanger, of course, this is very basic sense only. Wherever the friction, 2 movement parts, rotating parts, where the friction is happening, because of the friction, heat is generating. This heat can be removed either with the help of air or with the help of any fluid like a water or glycol or any fluids. So these are the 2 media of which is required to cool the substance. Heat exchanger, types of heat exchanger. Of course, shell and tube heat exchanger is a very traditional heat exchanger. Everybody knows about the shell and tube heat exchanger. And there is a pipe and pipe heat exchanger. Generally, it goes into some food industries and some refrigeration, especially the pipe and pipe heat exchanger, which goes into the refrigeration applications for cryoscientific applications. And the next one is fin and tube heat exchanger. Generally, this is like in a radiator. The one for the fluid which will get cooled with the help of atmospheric air. This is a fin tube heat exchanger. And there is one more product, that is immersion coil. There are some applications like anodizing plant, phosphating plant, and those applications, instead of the inside the tank to maintain the temperature, to attain the quality, maintain this the result, they circulate the chilled water inside that coil. So this coil is generally putting place inside the tank. So this type of heat exchanger also available in the market. And another one is electric heater. Of course, everyone knows about electric heater. And the next one is plate heat exchanger. In the shell and tube heat exchanger, there are some issues. And generally, this shell and tube heat exchanger, it is which will have the lower U values, that is heat transfer coefficient, because of the laminar flow. And the shell and tube heat exchanger can be manufactured with a very cheaper price. See, in generally the plate heat exchanger, the size is 1/3 of shell and tube heat exchanger because of the high heat transfer coefficient value. For example, to perform, let us say, for example, 100 kilowatt. To perform the 100 kilowatt heat duty, suppose the shell and tube heat exchanger, which will require 10 meter square, means the same heat duty with the help of plate heat exchanger, we can do the same performance with the 3 to 4 meter square. This is more than sufficient to perform the same duty. This is happening because of the high turbulence and the plate corrugations and the plate designs. So that is the reason which is one of, in terms of size, 1/3 of shell and tube heat exchanger. The another major advantage of plate heat exchanger, the cleaning, in terms of maintenance, it is 100% possible. You can open the heat exchanger and to do the cleaning activity on the both the side. Whereas in shell and tube heat exchanger, 100% cleaning is not possible. Only the tube side you can do the cleaning. Whereas the tubes outside, there is shell side, which is not possible. And the fouling factor also, in terms of fouling, the plate heat exchanger fouling is very less because of the inside the channel velocity. Whereas in plate heat exchanger, inside channel velocity is very high, so which will not allow the substance to, which will not allow the substance to foul the inside the heat exchanger, which will take a time. Whereas in the shell and tube heat exchanger, the inside the low velocity is very, very less, which will allow the substance very fastly. And during the maintenance time in plate heat exchanger, it doesn't call for now to remove the pipe connections because all the pipe connection which is located on the front side. So it is not required to remove all the pipings. Whereas in shell and tube heat exchanger, you don't have option. You have to remove the pipeline and then do the cleaning activity. This is another problem. Another major advantage of plate heat exchanger, suppose if at all in future, if you want to increase the capacity of your equipments, or in case of any shortfall in the performance, which can be eliminated with the help of by adding the number of plate. You can enhance the plate heat exchanger capacity by adding the number of plate. Whereas in shell and tube heat exchanger, it is not at all possible. Once installed means installed. There is no way of adding, increasing the area. You have to put one more heat exchanger. So that is the only option left with the shell and tube heat exchanger. So this is the major advantage of plate heat exchanger when you're going with any heat transfer. And in terms of structure, it is very less weight, and so that suppose for the chemical industry or pharmaceutical industry, there are a lot of heat exchangers are placed inside the structure. Like they call it is a primary condenser cooler, secondary condenser cooler, sub cooler, like that. Whereas in the suppose if they are going with the plate heat exchanger, because of this less weight and the compactness, the entire structure itself, which will become very less, and the structure cost also will be very less compared to the shell and tube heat exchanger structure. So these are the major advantage of plate heat exchanger. Sir, please be on the line. Just we are showing the plate heat exchanger construction through with the help of some animations. Sir, can you see this one, sir? Hello?
Yes, sir. Yes, sir.
Yeah. Sir, this is the single plate. This is the single plate. You can see the corrugations, and every plate will have the 4 port, and the black line, this is the rubber gaskets. This rubber gaskets plays the vital role in any plate heat exchanger. So every plate will have one rubber gaskets. See the first plate which is going inside. See, if you see the gaskets, the first plate, you can see the black mark. All the ports are ring. This is covered with complete gaskets, rubber gasket. So there is no way of escape the fluids which is passing through the heat exchanger. So the first, the blue frame and the plate, the first, there will not be any flow because of this restriction. Even this restriction also, you can see the 2 black line. That is two black lines are there. Even one black line, if at all any issues, the fluid which will try to escape through this one. But again, there is one more barrier, the black line. So whatever the fluids which comes out here, there will be inside, there will be one vent will be there, so that through that vent, the whatever the substance gone inside, which will come out. So absolutely, it is 100% protected gaskets. So this we call it as a start plate and start gasket. And this, you can see the second plate. Second plate also same corrugated plate. Only the difference is the first plate. You can see all the ports are lined with the black black line. This is a barrier, whereas in the second plate, only the two ports are covered. This opposite two ports are, there is no barrier. So whatever the fluid which is passing through, which flows through the plates. So this is how the plates are stacked with the help of rubber gaskets. There are number of plates which basically based on the capacity of the heat exchanger which we decided. So this is how the construction of inside. So the number of plates are stacked together with the help of rubber gaskets, placing between the two frames and the tightening with the help of tie rods. See, all the ports are, see, if you see here, all the ports are connected in front side. So if at all in maintenance side, of course, I told you, there are no need to no removal of this pipeline. So because of this, all the ports are placed in front of the frame. So this is how plate heat exchanger looks. So this is the second animation. This is the another heat exchanger animation. Basically, this animation, through with the help of animation, you can understand how the substance flows inside the plate heat exchanger. See, always in the heat transfer, the red mark, red color, which indicates the hot fluid, and the blue color indicates the cold media. See, if you see that here the hot fluid, which is, suppose if it is hydraulic oil cooling application, the red, it is referring the hydraulic oil, which is entering here. And this is not this is a completely uniform distribution. Once it enters here, which will hit the last plate. The last plate, there will not be any hole, which we call it as a dummy plate. So the moment it enters here, it hit the flows hit the last dummy plate, and it will and then it try to escape. So because of this gaskets arrangement, if you see here, there is no gaskets, and next plate, the same directions, there is a gaskets. So every plates, every alternative plate, there is a opening, closing. So once the word enter here, it is the last end plate, and wherever the port openings are there, which falls from the top to bottom. And the bottom side also, if you see the opposite, there is no black hole, no rubber restriction barrier. So whatever which is going inside, which will pass through this way, like outlet. So the hot is which is entering here, the same which is coming out here, the bottom side. And in the same manner, the cold fluid which is entering here, the moment it enters, it hit the last dummy plate, and then it will pass through the bottom to top. You can see the arrow mark, blue color. So because of this alternative flow arrangement, now one side hot, the plate one side hot, other side cold, oil, water, or oil, water, like that. So the whatever the based on this now capacity, temperature, thermal length, and the flow, we decide the heat exchanger size. Generally, the heat exchanger size, we select the nozzle size based on the flow rate. Once the flow rate selected, and based on the heat duty, like a thermal duty, like a temperature difference, 5 degree, 10 degree, And based on that, we select the models which is available with us. So we are having almost 45 models which are available with us. And in terms of connections, we are having it from starting from 1-inch connection up to 20-inch connections. We are having the almost 20-inch connection size of heat exchanger. This 20-inch connection heat exchanger, generally it goes into the steel industries, power industries, and nuclear powers, and big steel plants, power plants. Normally, this steel plants or power plants, the volumetric flow, which will be somewhere under 1,200 m cube or 2,000 m cube like that. So those kind of fluid, handling this 2,000 m cube, we are going with the 20-inch connections heat exchanger. Sir, any doubt on this working principle, sir?
So you can go ahead. Finally,
Yeah.
people will ask questions.
Okay, sir. Okay, sir. So this is small comparison for small, the shell and heat exchangers. The size is very bulk. When you compare to plate heat exchanger, it becomes a very small one. This is small comparison. This is how it looks. And this is now we are going to talk about a small implementation which we did it in Ashok Leyland Sri Perumbudur plant. And of course, last 1-2 years, which we keep approaching Sri Perumbudur team, there was an temperature issues, and we keep on touch with the customers, our people. And then finally, they also understood that there is issues in terms of the heat transfer. So earlier, before implementation, the oil tank temperature was around 55 to 60 degree. And the total number of circulation pumps which were there using 3 circulation pump, one circulation pump of 11 kilowatt and another and the total number of PHs, total 3 heat exchanger they were using it, one plus one oil chiller. And the total hydraulic power consumption was 490 kilowatt. This was the before implementation. This was the scenario. So this is a picture we took it from your plant. This is earlier the temperature was around 55, less than 55 to 60 degree, which were the maintaining. These are the heat exchanger they were working. This is PHE1. This is another one heat exchanger. And there was one more heat exchanger. Other than this heat exchanger, they were running with some fans also. The moment you enter into this place, it was so hot. So people are placed some fans also to remove the because of this high temperature, the entire area was very, very high. The people are not able to enter. So they placed some fans also. Now we did this implementation. What we did, we took intake complete. We did the studies and we took all the datas, current datas from the team, and we did the design with the heat exchanger. And now this, if you see that the same hydraulic system, now they could able to maintain the temperature of around 48 degree. And the same duty is now performing with only one heat exchanger. There is no all the other heat exchangers and the fans, everything was removed. And the circulation pumps, now it has become 1 in place of 3. And this chiller also removed, fan also removed. Now this hydraulic power consumption has reduced from 410 kilowatt to 285 kilowatt. There is a drastic power savings right now it is happening. And this is not something like, which just like that we are not telling. This is actual figures which we right now, which is running with your plant. See, now the temperature is 48 degree. This is the single heat exchanger right now, which is performing the same duty. And the fans, everything was removed. And of course, we also suggested to, to change some of the pump flow also we suggested some flow. Even if you do that modification of pumps, again, you could see the still better performance. Hello, sir, this is what we did it in our Sri Perumbudur plant, sir.
Members, the speaker is asking queries for your side.
See, whatever we have shown, that is not something like only figures, which is happening practically in your plant. Yes, sir.
Mr. Shirang, sir. Yes, sir. Tell me, sir.
Sir, go ahead. Shoot your question, sir. Hello.
I think by mistake you must have pressed the hand symbol.
Oh, sorry. Sir, now.
Are there any questions, gentlemen? I think there is one person who has raised his hand.
Yes, sir. Mr. Shirang.
Yeah, Mr. Shirang, do you have any questions for the speaker?